Your FastMCP tools work perfectly, but do they look as good as they function in client interfaces? We'll add a visual identity to a calculator tool by attaching an icon that appears whenever AI models or users browse available functions. You'll see exactly how the icon type integrates with tool decorators to create professional, recognizable components.
From MCP, types import icon. At MCP, tool. Icons equals icon, src equals https://example, com/calculator icon, png. Def calculate sum a, int b, int. Add two numbers together. Return a plus b.
This demonstrates the declarative tool registration pattern, where Python functions become remotely callable endpoints through simple decorators. The key concept is metadata-driven development. Instead of writing explicit API routes or RPC handlers, you annotate functions with @MCP tool and let the framework handle exposure, discovery, and transport. What makes this distinctive is the complete separation between your business logic and the RPC infrastructure layer. The pattern works by treating decorators as configuration contracts rather than imperative instructions. At runtime, the framework introspects decorated functions, extracting type hints, docstrings, and metadata to auto-generate complete API schemas. This creates a clean boundary where your implementation remains pure Python, while the decorator handles all RPC concerns, parameter validation, serialization, and endpoint registration, without requiring you to write transport-specific code. This approach matters because it eliminates the traditional friction between backend logic and remote accessibility. You avoid writing boilerplate for routes, payload validation, or documentation, while gaining automatic client SDK generation and type safety. It's particularly valuable for AI integrations, microservices, or any scenario where you need to expose capabilities to external systems without coupling your core logic to specific transport protocols. The trade-off is framework dependency, but the productivity gain for RPC-heavy applications typically outweighs this cost. Let's break it down line by line.
From MCP, types import icon.
This imports the icon type from MCP's type system, enabling type-safe icon definitions for tool metadata. Required for the @MCP tool decorator to validate icon configurations at compile time.
At MCP, tool. Icons equals icon, src equals https://example, com/calculator icon, png.
This decorator registers the function as an AI callable tool in FastMCP. The icon's parameter assigns visual identifiers for UI display, using the icon type to specify image sources. This follows FastMCP's tool registration pattern, where metadata like icons and descriptions enhance discoverability in AI interfaces. This closing parenthesis terminates the @MCP tool decorator declaration, finalizing the tool's configuration. Without it, Python would raise a syntax error, preventing the function from being properly exposed as an AI callable tool.
Def calculate sum a, int b, int.
This defines an AI callable function with strict type hints. The parameter and return annotations, a, int, b, int, enforce type safety and automatically generate the tool's schema for the AI model, eliminating runtime type errors.
Add two numbers together.
This docstring defines the tool's purpose and behavior for AI models. It becomes part of the tool's schema, enabling proper discovery and usage by AI systems. Always include a clear, concise description for every AI-exposed function.
Return a plus b.
This implements the core calculation logic, performing the actual addition operation. The simplicity ensures reliability, while the type hints guarantee valid integer inputs. This is the minimal viable implementation pattern for AI callable tools where the function body directly executes the described operation. Visual tool design pattern. Icons in FastMCP Transform Abstract, Python functions into visually identifiable components, bridging the gap between code and user experience through simple URL-based image references. The icon's SRC field is mandatory, while MIME type and sizes remain optional, allowing progressive enhancement without breaking basic functionality. This single decorator line makes tools instantly recognizable across all MCP-compatible clients without modifying the underlying logic.
The icon that points to nothing still illuminates everything.